Okay, I thought I'd make some more video on the 3-axis. Really, this is an open loop stepper motor system that I'm doing right now. I think somebody posted on my last video what happened to your servo project, and quite frankly I haven't even started it yet. I need to finish this one, test it, and sell it so I can use that money to go to my next project and probably pay some bills I'm behind on because of the slow economy we're having around here in Midland, Texas. Anyway, this is where I'm at. So when I do sell this, I'm going to include the laptop, which is a small, minimal resource laptop that works very well with this system that has Windows 10 Professional on it. I'll just configure it as a local operating system as a MACH 3 user, and whoever makes the purchase can configure it how they want. But the machine itself will be pre-configured, and we're about to go over firing the machine up. We'll do some movements with it. I apologize for the noisy fan, but it tends to be in the triple digits every day here. So out in the metal building garage at my house, it gets quite warm. There's no insulation in here, so I've got to have the fan. Anyway, down on the floor there is the 3-axis controller and the control board via USB. So we've got 1, 2, 3 drivers. There's a place for a fourth one, although when I put this in the enclosure it may be a little different arrangement, but I can assure you it will be pre-wired and pre-configured, ready to run. So basically what I had to do is come in and pretty much secure the cables and the IGES flex chain that I used. I just have it suspended below. I have that strap back here on some aluminum extrusions on the back right here. And then I have 3 plugs. And by the way, I didn't just crimp the ends on the plugs, I did solder them before I inserted the plug ends. And same way over there on the Z-axis, the X-axis. Now the Y-axis is stationary, doesn't move, so its plugs are a little more accessible and exposed. But I think that's just fine because there's no... Your X and your Z there, X and your Z have to move up and down and horizontally. So I put some momentary plunger switches on for limits and homing and homing and homing on the Z. So I had to do that. And I still want to get some covers over the ball screws and properly over the motor couplings. And basically just have some shields in between here and to here to cover those ball screws. Now when I put the spoiler board back on here, the Y-axis ball screw will be covered. But I want all of the screws to have a certain amount of dust covering protection on those. Oh yeah, and I also had to add the greaser connections because the ball nut is way back in here and there's just no room to get in there. So I had to add a hose extension, and I brought that out right here on that one. And then for this one down here, I went ahead and mounted a greaser right there. And there's actually one around here on the back side. That's a little more difficult to see. Right up underneath the Z-axis, right here we kind of have a flex cable. So that Z-axis screw can be greased. And all of these screws are C7 precision, 16 millimeter diameter, 5 millimeters linear per rotation. So that sums up the machine. And of course it is all built out of aluminum extrusions, bolted, sheeted 1/4-inch 6061 aluminum plate. And there are actually 5 extrusions There's 1, 2, 3, 4, and then braced on the bottom below the table, there's 5. And I've got another stabilizer here that's a 1x1 6. So this is a very stable and zero backlash table. I have built some in the past that I was very disappointed in, because you would be surprised. You try to go lightweight on this stuff and you find out that there's just too much backlash and play to produce good parts. So what I'm doing here is hopefully producing, not hopefully, I am producing a machine with good quality 20mm slides, recirculator ball bearing bushings with wipers, ball screws with greasers, limit switches, homing switches, all mounted on rigid, but as light as possible, lightweight aluminum extruders. And I even did the same thing with the 2 horsepower router that I have mounted here. To thicken this plate, I added these, which also allows us to slide the router system up and down, depending on how long our tooling is. So if we need some longer tooling, we can actually adjust this up a little bit. Or shorter tooling, we can bring it down lower. I think I've got it down where it should be for most tools right now. You can run 1/4 inch, 1/8 inch, and 1/2 inch in there right now with the collets I have. So I guess that about sums up the video on the general structure of the CNC gantry. We do have dual shaft, 4 25-ounce NEMA 23 motors mounted. The thrust bearing takes up all the load. They provided these aluminum couplings, and they're not bad. They do allow for quite a bit of misalignment. And if you decide to build one of these machines yourself, you will definitely appreciate that. It works pretty well. And the backlash can be adjusted in the MACH, but I haven't really noticed any major backlash with my machine yet. I've done some cutting with it already, but I didn't have all the limit switches and wiring, as you see up here, protected and encased in flexible jacket. Yeah, it would look nicer with some cable carrier. And but that's just where the cost of this machine. This is a lower cost machine, but the performance is going to be quite superb for what it is. I'm already rapid traversing at 70 inches on each individual axis and up to 90 inches a minute on diagonal moves. Okay, I'm going to wrap this video up because they get a little bit long if I don't, and I'll go over setting up and firing the machine up next, and we'll make some movements with it. And then I'll put a spoiler board on it, and at some point, I promise you, it may not be today, you'll get to see some aluminum cutting done with this after I get the cool mist air and coolant connected up. So stay tuned.